Do we start with this? Yes. Does it work? Can you hear us? Perfect. Cool. So we'll talk about PanGEO, and I mean, we already had an introduction of PanGEO every second day this week. Someone mentioned PanGEO, but we were not so sure that you really know what is PanGEO. And discussing with some of you, obviously, it's not very clear. And I won't say it's very clear to me, but at least we will try to clarify what is PanGEO, what we think is PanGEO, and how we can move forward. As you can see, there are many names on this slide and on the first slide. And actually, we cannot put all the names because, as you will see, PanGEO is more community-driven. It's more about people, and they are contributing. And if we really want to put all the names, we will spend half an hour listing all the different people who have contributed. So very often we say the PanGEO community. But here, that's the main people that really help to set up the tutorial and the presentation today. So first, what is PanGEO? So now let's try to dig it out. So it's a global community initiative for big geoscience data. And already when you see big geoscience data, it means this is quite an old initiative because we don't talk about big data geoscience anymore. We have much more flashy ways to talk about big data analysis. We also usually mention AI, which is not here because if you don't say AI, it's not so cool anymore. So it means this is not, it's quite a mature community of people, and it has been around for quite a while, maybe the last 10 years. And it's an open community, it's open platform and open deployment, and you can try it yourself. So really the goal is not to lock you in any system, is to make sure that you can go from the laptop to the HPC or to the cloud. You can be a software developer, you can be an end user, a scientist, a policymaker. Everyone should be able to benefit, but also to contribute, because nothing is really free. When we give you resources, we say we give you free storage, free computing, but there is always someone behind who pays for it. It can be your university, it can be your institution, it can be European Commission, whoever is behind, there is someone paying for the resources. And if they are paying, we also need to give back. So we also need to contribute. So that's the idea. So what is an open community? So the PanGEO community, we have like a long-term vision, which is to try to be more equitable. So more equitable, it means we try to help people that sometimes do not have access to the big data storage or to big computing. And we try to help them to get access to these computing facilities and storage. And we also try to train them on how to exploit them more easily. Because if you are in a big university and in a very rich country, you will get educated, you will have the training, but if not, you will not get it. And why? If we really want everyone, for instance, to combat climate change, we need to give them the opportunity to get the data, to get the computing, and to show that there is also a problem where they are living and not in your country. So this is what we are trying. It doesn't mean we are always successful. It means we are trying. So it's a culture of collaboration. And here we try to put some of the logo of people that are contributing. But like on the first slide, if you really want to put everyone, you cannot. It's too big. There are too many people and too many organizations. So usually when we do a presentation, we pick up some of the logos and we try to put and highlight maybe sometimes people who fund or paid for the traveling, etc. But the idea is really this is a global community and we try to collaborate together. But if I only have people, it's useless because we need more than people. If you have people on one side and you have infrastructure on the other side and you don't meet together, what can we achieve? Nothing. So we need to have also open platforms. So we want to have platforms that you can deploy anywhere and still have the same environment so you can continue to work. What you learn one day can be reused another day, and you don't have to change completely because someone decided to put money in some other initiative. So the PanGEO, it's an ecosystem. So you understood it's driven by people, but it's also a very large ecosystem and also an open ecosystem. So it means this is moving and evolving because there are new packages coming or people are developing new things. So it's some people are adding things or removing things, and this is a community-driven agreement. What is important for PanGEO to understand this is based on these pillars. You have the user interface, and most people believe that PanGEO is only based on Jupyter and Binder. It's not only. We will see there are different interfaces, and you can also use the PanGEO ecosystem from the command line. So, but you need to have a selected choices on a user interface. Then you have a data model, because that's very important. How do you access the data and how do you manipulate the data? And one of the basics in a PanGEO ecosystem is the data model is based on X-array. So X-array is a way to handle coordinates and to manipulate variables. We will see in the tutorial, but it's a unified way of trying to unify the way we access and manipulate and compute data. Then you have the storage, then you have the hardware part. You have the storage system and the resource management system and the scalable compute. The thing is the storage. If you are on a laptop, your storage is different than if you are on the cloud. And it's also different than if you are on a HPC or HTC, because now I learned this week I need to use the word HTC. It's much more trending. But so you will have different file systems because they are optimized for the platform. And this is very important. And this is what is flexible. It should be hidden enough to the end user that you don't have to say, change your code because you are moving from your laptop to the cloud and then to the HPC or HTC. And that's the same for the scalable compute and the resource management. If you are on your local laptop, you don't really need to have a resource management very sophisticated. You start your, for instance, Jupyter Lab, you can do your analysis, and that's it. There is no queue, there is nothing like that, because you are on your own and nobody is interfering with your work. But you can see very quickly that you don't really scale. So we need something else, and this is what we have in this resource management. If you are on a HPC or HTC, you usually have something like Slurm, which is what we have used this week. If you are on the cloud, we usually use Kubernetes for managing all the different tasks. And then in the PanGEO ecosystem, for scaling, we usually use Dask, which we have talked about a lot this week. So the idea is really to be able to help you and to facilitate to move from the laptop to the cloud and to the HPC. So here, this is just one slide about, I think we have 2 slides about this. How do we really scale with Dask and what is Dask? And this is also what you will experiment in the tutorial. So the idea is always to divide to conquer. You know, when you want to parallelize, because it's too big and because you have too much data, you need to divide it. And this is exactly what we have seen this week. On the first day, manually, we divided the big image of large image, you divide it in tiles or in chunks, and you analyze each of these chunks in parallel. And we learn how to do it on a HPC or HTC with a job array, for instance, or with a loop. So you learn how to split your job to make it scalable. With Dask, you do it exactly the same way, but everything is delayed. So you create your operation, like if you want to minimize, if you want to make a mean, if you want to do a seasonal mean, etc. You chain all your operation. Then there is a graph that will optimize all the different operations, and then you will send it on either your laptop, on the cloud, or on the HPC. And this is what we will see in the tutorial. Do I need to show this? Yeah. Maybe. So the idea is when we are on the laptop, you don't really have the workers or the parallelism is very limited. This is a number of cores you have on your laptop. Not so many, much more than what we had a long time ago. So you can do some kind of parallelism, but you will be very limited in the number of tasks you can have on your laptop. When you go on the cloud, you can start to have more workers, but again, it depends on what infrastructure you have behind. And the idea is to have some kind of scheduler where you can define when you have a big image, you will split your image and you will say, now I want to work and I want to have like 10 tiles or 10 workers, and they will each work on a portion of the image. And this is what we will do in the tutorial with a very simple image. So that's the idea behind. And you can do this on the cloud and on the HPC, and the code itself is the same. You only have to change very little in your code. So the idea is to be able to deploy it anywhere and for everyone. What does it mean? So you can have it on a laptop, and what does the PanGEO community is to maintain a set of Docker images, also a computational environment, Panda environment, with all the packages we think are relevant for this community. And sometimes you can say, yeah, but my package is not there. You can make a pull request and it can be added. And as you know, in our communities, this is sometimes very hard to have everything compatible. So this is why the creation of the images, everything is automated. So we are sure when we are delivering an image, this is compatible and it is usable for the end user. Then you can make on the cloud. And on the cloud, it's nice, but most clouds are private or behind a wall. We have seen with the Copernicus, we can access it, but then we are always limited in the number of jobs or a number of tasks we can use. So what we are trying at the PanGEO level is to provide public clouds, public access to people, at least for being trained and for entering the PanGEO ecosystem. So to be able to learn. And this is what we do with this PanGEO at EOSC. Which is a public deployment that anyone can access and can try it out. We have different images. So we have the machine learning notebook with TensorFlow, with PyTorch, and we also have the standard Jupyter notebook with PanGEO. And then we have, also, of course, on the HPC or HTC. And this is also what we will see here. We can easily scale on a HPC, and you will try it out on exactly the same HPC or HTC you have used during this week. And there are many other deployments on the HPC. You have one at Ifremer, I guess, and they have one in Clash, etc. Yeah. So maybe I go quickly here. I think the idea is if we want people to be able to be part of a community, you cannot only be, you want to be infrastructure agnostic, but if you don't provide any deployment, people cannot even try what you have. So the idea is also to have infrastructure or to get some deal with some infrastructure provider, so we can give the community an access and a way to try it out. So this is what we did with EOSC. So here, this is how it is deployed, and I don't think this is very useful at this stage. The idea here is we give a way to authenticate, and then you can access it through the cloud. And we will see in the tutorial. So what we wanted to go is one step further. Is we are training you today, but maybe tomorrow you want to be the trainer. Maybe tomorrow you want to train and you want to use this infrastructure to teach your students. Then we have developed the concept of PanGEO training infrastructure as a service, which means if you want to train, you can request resources, and then we are discussing with provider on how to give the resources so you can train your students or your researchers. So we have done some of this training, and what we are doing is very simple. This is ad hoc. We have like a Google form where you can request. I will have a training. I will have 20 or 25 students. I need this kind of infrastructure. Can you give it to me? And then we try to discuss and give it to you. Last part is, it's good we are talking about the PanGEO community, but we don't want to be isolated. We don't want everyone to be in the PanGEO and say, no, you should be PanGEO and that's it. And this is a bit what most people are talking about. And I really like your talk because you talk about federation. So most of the time, we want people to come to you, but you don't go to the people. We always say, what I do is the best, so do what I do, and everything will be interoperable. So the idea is we want to team up with other people. We want to meet people where they are. We want to understand how they work. And we also want to get from them the way they are working, because we think this is also how we can improve ourselves. Because if we only stay and stick together, we will all agree and we will say, yes, we are the best. But everyone else outside will say, what are they doing? This is nuts. It doesn't work for us. So we really need to go outside and challenge ourselves. So we need to go where we are not, and where we would not go by default. So for instance, we team up with Galaxy. So Galaxy is more for biology initially, but they were interested in analyzing climate data and also Earth observation data. And we could say, just come to us. But we say, no, we are coming to you. And we want to understand how you work, and we will adapt to your infrastructure, and we will try to set up something that is useful for you and for your day-to-day work. And this is what we are trying to do. So we are trying to wrap some of the tools we have in the PanGEO ecosystem in their framework. And it's also a way for us to understand what do they do with our data, with observation data. What kind of data really do they need? And as you mentioned, most of the time we talk about global data. They don't care about global data. They want very easy access and small, very tiny data on a very specific area. So they tackle the problem in a very different angle, which I think is very useful for us too. And this is the same also. We team up with the Environmental Data Science Book, which is an initiative from Alejandro Coca-Castro in UK, from the Alan Turing Institute. And the idea behind was, okay, now we do a lot of Jupyter notebooks. We will also show you the Jupyter notebooks. But a Jupyter notebook can be a spaghetti code, totally unreusable. And we can say, yeah, you can click on the button, it will execute. Yes. But can you build something new out of it? It's very hard sometimes. So we thought maybe if we try to add some practices, or we try to agree together on what can be a Jupyter notebook that can be reused by someone else, who is not necessarily working on the same problem, but maybe can reuse some part of it. And this is quite a challenge, actually, because it's not that easy. Then the last part, and this is also where I'm very happy to be here. We also are very interested in this, what we call GeoPythons community, which I believe you belong, because I'm more for the climate and global community. And we also would like to understand, and I learned a lot this week on how you work and how you handle the data, for instance, with GDAL, which I don't necessarily use on a day-to-day basis. And one of the projects we have now is called JupyterGIS, and it's ESA Digital Innovation Project. And the goal, at least on my side, is really to understand how you work and how we work and how we can bridge the gap between the two communities. Last but not least, this is how we will work today. So today you will have the different ways of working. Yesterday with Michele, you used the cloud and the Copernicus data space. So you have authenticated, and you can start to do a Jupyter notebook. And we saw that you have different kernels. You can still use that today, because it's domain agnostic, and you can have the PanGEO ecosystem. You can add packages. You will be able to use also the PanGEO EOS, so you also can register and get it, and we'll show you how to do that. But you can also use on the HPC, and the same notebook, with very few changes, can work on your laptop, on the cloud, and on the HPC. And this is really what we want to show you, that you shouldn't have to change a lot of your code because you go from one platform to another. The infrastructure behind should change and optimize for the infrastructure, but as an end user, you are not supposed to change a lot in your code. So on SURF, and thanks to the eScience Center and to Raymond here, we also set up, I didn't do anything, I just tested it actually, a Jupyter lab, where we can scale, so we can send jobs and workers on the nodes to do a large data analysis. So this is a component they have developed. I don't go into the details now because we will see it in the tutorial. Just to say that this is not our work, this is something that has been done. And again, this is the idea behind this. Because it's a community-driven, it means people, instead of having each individual here trying to port it on the surf, it would take a lot of time. Some of you maybe be quick because you are used to work on a HPC. Some other, it will be much longer. Or maybe you will fail and then you will give up because you will say, what is this machine? It's not interesting. Then the idea is one people or one group set it up and give it to everyone. So one person does the work and everyone else benefit from it. That's the idea behind. Last, I think that's the last slide. So remember, it's a community-driven. If we don't have people, we don't have a community. When you are using Xarray, Dask, etc., Jupyter Lab, you have developers behind. They need also to get money. They also need to get feedback. They also need to know if what they do is useful for you or not. So instead of blaming when you have a failure in your Jupyter notebook saying, oh, Xarray doesn't work for this, feel an issue. Tell the developer what is working and what is not working, because they can fix it. But if you don't tell them and you just complain about the package, they may not be able to fix it because they are not users. Developers are not using what they are developing, or very little. So they are developing. So for instance, I'm working with Min, with a JupyterHub developer. He's not using JupyterHub. It's just developing it. So if we tell him this is what works and what doesn't work, he can fix it. But if you don't tell anything, he cannot. So yeah, and same things for the Xarray. If you say it doesn't work, yes, sure. But people developing Xarray are not using Xarray. They are not even doing Earth observation data.
Some.
Yeah, yes, some, but
Yeah.
not all.
Yeah.
Okay, yeah.
They're not using really the big data.
Yeah, exactly.
Yes,
they
we
don't
are
do at
using,
scale,
so-
which is usually when we fail.
Yeah.
A few pointers where you can find information. And I think that's it. Now we have the hands-on.
Yeah.
Which maybe we can put on Discord somewhere.
I just share the link to the Discord to everyone. Yes.
Maybe you need to be closer to the right.
Yes. So what did you? Okay. So shall I more share the screen or?
Do you want me to share? I can share.
I can.
I stop sharing.
So what would be good is like if you can, we will maybe share the Jupyter book.
You need to share.
Yeah. Okay. Not this one. Shit, I had it. Share.
I think it should be already maybe in the.
Yeah. So,
yes, I think you already put it in the logistic.
Yeah. So in the logistic, I put it a link for everyone. So there. So if you go to so this one is like your GitHub that you can git pull. And did anyone? I came yesterday, so I don't really know. But did anyone have this link before or is this the first time you see this link?
I think this is the first time we see the link. So each day we a different training.
Yeah. So this link, it's making this Jupyter book here. So how many? So did anyone already created the account on PanGEO EOSC?
No.
No. Okay.
I think what you can explain is how you can get account.
Yeah.
And maybe at the end we mostly so to give them an overview of what they can try out.
We will just okay.
And we show EOSC and.
So maybe you can start, and then I will then jump into the Dask and so on. Yeah, let's do that then.
Oh, you mean me start?
Yeah.
Okay.
Because if you have that in already in the mind.
I don't know. Did you share? You shared.
Yeah, I shared.
Okay. Yes. Okay. Let's try.
Yeah.
So, are you on this page? Yes. All good? So here, when you get started, so you remember you can get started using the Copernicus data space from yesterday. How do I do a plus here? Okay. What is the address of data space? You don't have the data space? No. If someone remembers the data space. Dataspace.copernicus.eu. Where do you write here? Can we move this? I can't. Make it smaller. Yeah. And then move it down. Yeah. Up, data space. Yeah. So you remember this page, the dataspace.copernicus.eu from yesterday. So from this one, you can open, you can log in. You have an account? Yeah. Okay. Yeah, and you can, oops. And you see the Jupyter Lab here. You can start the Jupyter Lab. So I show you the different way of doing it. This you have seen yesterday with Michele. That's exactly the same. And when you start it, okay, access Jupyter Lab. Again, it's better to take the large server because the small is very tiny. So I need to start verification. I'm a human. And that's the same principle. So here, the thing is, we don't really know which packages they are installing because it's not the PanGEO image. And as yesterday you said, Michele, you don't even know which package is available or not. What we do in the PanGEO is we have a set of images and you can really check which package is there and which one is not. But so here you can do exactly like yesterday. When you have the Jupyter Lab, you can clone the GeoOpenHack GitHub, and you can try out the different Jupyter notebook. And most of them will work. And that's what I wanted to show you. It's coming. Yes. So here, if we do like yesterday, we would do a Git. Maybe this needs to be big. Where is the plus? To make it bigger. She has a French keyboard, but with a Japanese keyboard behind. And I'm used to the Norwegian keyboard.
Yeah. So we do the Git clone, maybe?
Yes, do the Git clone.
No code. I go with HTTPS.
Yeah.
Yeah.
Yeah. So when we clone, we make a copy in the cloud in this Copernicus data space. And if you look at the folder afterwards, we have a doc folder because we are building the, yeah, and you can go, for instance, in the PanGEO folder. And from the PanGEO folder, you have different Jupyter notebook. And like the introduction is XRA, then you can go to visualization, which is more interactive visualization. Maybe you can show and open it.
So that's kind of this.
Yeah, that's the order here.
So we have this getting started with PanGEO, which will explain later. Yeah. So each notebook, basically, that we are showing here, if you click on the top, like XRA introduction, then it's corresponded to this notebook here with XRA introduction. So you just need to try to learn and start to see if it works on your infrastructure. And if it doesn't install, and then you need to always do this.
Yeah. Okay. So one thing I want to show you is what I mentioned before. We are trying not to have a Jupyter notebook, which is a spaghetti code. So what we think is also important at the top is who made this Jupyter notebook, who contributed one way or another. And also, at the very end, I don't think we'll see, maybe we have to go to the, no, I want the HTML like this one. Yeah. If you go at the very bottom, we want to cite the packages. Who is citing a package when you make a paper? Very good. Thank you. So it's very important we cite packages because you cite all the paper when you do an introduction, when you write a paper, you cite a lot of people, but many times we forget to cite packages. And then when we are asking for money, for funding, for getting new developments, they always say, but do you have, who is using your package? Who is using XRA? Many people. Who is using Jupyter? You know how hard it is to get funding to develop Jupyter?
For me, yeah.
It's very, very hard. Everyone is using Jupyter. Everyone is deploying Jupyter, but no one is citing the Jupyter package, including myself. I was also, yeah, yes, that's true. I don't do it. This is a good practice. And this is also what, when we talk together, we say, yeah, I think it's a good practice also to say, who did this package? What am I using? So at the bottom, we try to do this package citation. We try to find out, and sometimes they don't even have a digital object identifier. Sometimes they don't even have a citation, but we still enter something in a BIP text, and we put the link to the GitHub repository. And we put all the GitHub username in the contributed to the repository, because we think it's important. So this is what I wanted to mention here. Don't forget to cite the people behind the scene and that are working very hard to make it easier for you. So in each Jupyter notebook, we'll try to show you how what is XRA. So not everyone knows XRA. No, who doesn't know XRA? Good. So when you will open this introduction to XRA, we are trying to go step by step and explain you what is a XRA. So we are fetching some data, and don't bother too much on the data. You can try also with your own data. XRA is a Python package that can handle many different types of data, including GeoTIFF, GRIB, NetCDF, HDF. So it's quite rich, but sometimes you need to know how to open it, and you need to make sure you have the backend. Like if you want to open a NetCDF file, you need to install the NetCDF package. If you want to have GeoTIFF, you need to install the XRA. Yeah. And so we are trying to show you here we are loading some data. It's a NetCDF data. When you load XRA data, you don't load it in memory. And that's the idea behind is XRA and Dask is you only load in memory when you need it. So if you have a 2 petabyte of data and you open it, you don't want to have 2 petabyte in memory. Anyway, you cannot, even if you have a big supercomputer. So what we do is only read the metadata, and then you will have some operation. So usually, and especially most people are not working on the global scale. Usually you want to extract an area, you do some computation. So what we try is to chain all the computation. And then when you are ready to compute, you ask to compute. And when you compute on your laptop, it will compute sequentially. But when you are on the HPC, then you can distribute. And this is what you will show later. So in this one, we are showing what is a XRA. When you load the XRA, you usually have what we call a data set, where you have the dimension of the grid. So it's always gridded data. It's not vector data, it's raster. And you have the coordinates. Here we have longitude, latitude, level, and time. And then you have a set of variables. And most importantly, you have a lot of attributes, which says what data you have behind. So you have like here the title, you have the source, where does it come from, who made it, how it was made. And usually they also try now to add some identifier, unique identifier. So you can, when you publish, say this is the data I used in my analysis. And you can access the different fields. So here, for instance, when you load, you have this coordinate and you have the variable. So it means if I enter the name of the variable dot one of the coordinates, then I will access the coordinate. But again, I don't access the values. I only access the metadata. Only when you go to the data, to the values, which is a NumPy behind the scene, then you will load the data in memory. So everything you do at a high level in X-ray is not loading data in memory. So when I do this, at some point I will have the array values. Then when I have the array, I have it in memory. And we have different ways of accessing. So this is what we are showing here. And if you are familiar with Panda and GeoPanda, you are familiar with accessing variables using the name of the variable and not the indexes. So it's really what is behind the idea of X-array. What else should I explain from X-array?
Attribute?
Yes, so the attribute can be accessed through the dot attributes, and you can access the global attribute with the name dot attribute or attributes of each variable, because the idea is always to have an attribute of the data set, but also of the data array.
So what is also interesting is like when you make a computation, you might want to change that, for example, like a meter to the another kilometer and so on. So we can use the unit with X-array. So there is a package especially developed on the X-array for unit conversion. So that's very important that you think about that when you make your own X-array object, to put the unit and also check this unit to things. But so then people don't need to make their unit conversion by themselves, but rely that on the X-array product.
Yes, so because the idea behind when you do a X-array and you manipulate and you do an analysis, you need to think you are becoming a data provider. Even if you are only a researcher in your lab and you want to make a publication, you are becoming a data provider. So you need to add some metadata to your data to make sure they can be reused. So we want people to be able to reuse, for instance, your Jupyter notebook or your package or your everything, your software, and also your data. But if you just dump the data as is without any information what is in the data, what is the unit, etc., it's not so reusable or less reusable. So try to make it more reusable using these attributes.
So should we let them also start to learn it on the?
Yeah, I think yes.
Yeah, or they should for the EOSC. Do they use the one on EOSC with the DAS gateway or not?
Yeah. So just one thing.
Yeah.
So here on the Copernicus, you will be able to run most of the Jupyter notebook, and sometimes you will see the package is not available, so you will have to pip install, and sometimes you also need to restart the kernel to do it. Make sure on here you are using, like yesterday with Michele, you are using the OpenGeoHub, which is the closest to the PanGEO ecosystem. As we have seen in all the presentation, OpenGeoHub is based on many packages. The geoscience is also a good one. And then you can run most everything. One thing you will not be able to run, is everything when we start to parallelize. So this Copernicus data space, you have lots of data, and this is how it has been presented. We always have the struggle. Either we have the data or we have the compute, but it's very hard to have both. And this is why we want to use object storage. Here you need to install push because it's not installed. But so, for instance, the Dask introduction or the Dask spider will not work on the Copernicus data space. So why? Because you cannot scale and you have no gateway behind, so you have no workers to make it parallel. So you can do small data analysis, even on the large image, because the resources are limited. Then when we want to go beyond, we need to go on an infrastructure where we have more computing and more memory, for instance, or globally. So this is where you can start using, for instance, the PanGEO EOSC. Yeah, you can.
Yeah, it runs.
I mean, most of the time it's just installing a few packages. And this is why we are creating these PanGEO images, because if you link your paper to the PanGEO image you have been using, and your Jupyter notebook or your code, and the data with a digital object identifier, then it's much easier for someone else to reuse the same data analysis on any platform. What do you do?
Showing the link to the PanGEO data page.
Oh, yeah, yes. The PanGEO, so all the PanGEO ecosystem is in the GitHub/PanGEO-data. And you will see you have many repositories. And you have like the GeoOpenHack, but you have the PanGEO image. And you see that it's very usually at the top. So people from the PanGEO community regularly create new images with different packages. And here you have like the PanGEO notebook, you have the Docker, and you have the environment. So here you know exactly what has been done, and each version so each image, Docker image, will be pinned with a date. So if you can say, I have this image from this date. What I would like in the future is we also provide the list of version to make sure as a metadata to know exactly what version we are using. But with this, not what we do here. And we have the PanGEO notebook. We have the PyTorch notebook, which is a machine learning using PyTorch as a framework. And the ML notebook is a machine learning framework, but using TensorFlow. That's it. But where is the yeah, this one. Yeah. So you can do a lot already on this data space Copernicus, and this is great. You can also do a lot on your computer already. You can take the image or create the PanGEO ecosystem. Once you want to scale a bit more, for instance, you will provide for, and this is free of usage, is a registration to PanGEO EOSC. So PanGEO EOSC, EOSC is a European Open Science Cloud. It's also a deployment of PanGEO, but on a public cloud that we give access to everyone. So it's of course limited resources. Resources are provided by Chestnut, and we have an agreement until 2027. So it means you can use this infrastructure, you can teach with infrastructure. If you really want to do larger computation, I think it's good to reach out, for instance, because we can have also agreement to have temporary deployment on specific computers. And maybe on Surf, we can have, why not? So here we give you in this registration.
Sorry, so this is on EOSC, yeah?
Yeah.
Yeah, but that's very nice, you know, because this is actually amazing that that's for free computation. So, yeah. Just if you didn't notice that, yeah.
Yeah, and you can use it after. It's not like we have a deployment for the course. You can use it after. Yeah, you have a question?
Is there any reason you never tested using Google Earth Engine with your infrastructure?
I'm sure we can deploy it on Google Earth Engine.
People doing it.
Yeah. So, and some people are doing it. Yeah. The thing is, what we want is also to have access where we don't want to pay for the infrastructure. And we also want to provide an infrastructure where people do not have to pay for trying it out. Then you can deploy it if you want to deploy it on Google Earth Engine, on Amazon. I mean, all these PanGEO deployment initially were deployed on private cloud. So they have all been tested, and they have configuration file like Helm chart on deployment on Amazon, on Google Cloud, etc. So you can already follow this.
Do you have some easy tools to visualize space-time data, like a time slider or something?
Yeah.
Yes.
Yeah, that's the next notebook.
That's this one.
Just to clarify one thing. So the first of all, with the PanGEO community, they got money from NASA, and with that money, they could buy the computing space on the Google and Amazon. So they were the PanGEO community were making this resource free, so because they got money, so they were letting this resource use for everybody from the world. But then of course, there's the end of the project that there's no more money, right? And in the US side, they were using Amazon and Google, but in Europe side, on our vision, we wanted to use something public, you know, like a European Open Science Cloud. It's based on the public infrastructure. So that's what we wanted to really do on European side, to show it's not only Amazon and Google which exist in the world, but we have the, you know, this Open Science Cloud.
Yeah, and we thought it was the role of EOSC
Yeah.
to provide such resources to people.
Yes, no, I think it's I agree fully, and that's also was a good point, that it's always some cost involved, so somebody covers the costs.
Yeah.
But you know, like, you can do the surfing, yeah, so you can use the wind and everything, and actually have your research done more or less for free, but of course sponsored by European Commission or network of resources, as Patrick mentioned. So there are always ways, yeah. So when you do the small scale things and for your own research, so yeah, that's the.
And even then, even like we get the funding one day for make this further in 2027. I think for us, it's important that we fund this European Open Science Cloud side, you know, and then so that it's not only funding on Amazon and Google, and then fund on the European side, you know.
I mean, one thing is in some institution, it's forbidden to use Amazon.
Yeah.
So in some institutions, for instance, when I was working at the University of Oslo, if I wanted to get credit on Amazon, I would not be able to do so, because they would say, but we have a cloud, or you need to be sure it's on the European cloud infrastructure. So sometimes you also have constraints that you cannot do whatever you want. Also, I think the idea is we should not be stuck in one infrastructure. As mentioned in the presentation before, we want a federation of different infrastructure, and we should be able to go from one infrastructure to the other without having to rewrite everything in our code, which is more or less what you do. If you do on Google Earth Engine, you are a bit stuck with Google Earth Engine, and it's very hard to move out of it because it's very powerful. And you learn how to do it, and then you cannot go on another infrastructure because you don't have the same level of capabilities.
And another point is this ingress cost. Yes. I don't know who is not aware about ingress cost. So when you put your data on your cloud, for example, in Amazon and so on, you bring data to Amazon, it is free. But when you want to download data from Amazon, you have to pay the network cost. So it's not, so that's another thing. Like afterwards, right now I put all the data in my Amazon. I want to pull it out and put it on European Open Source Cloud. You have to pay. So it's where is the free, fair data? You cannot, the data is there. You cannot access it if you don't pay. There is a problem, right? So that's also another reason that European Open Science Cloud, and something that, you know, of course, that we're using Chestnut, it's HPC Center. They are paying their network cost. So there's somebody's paying for network cost. Somebody have to pay it, but there should be some way to, that's something when you start to use a cloud, there's something that you should think about. For example, NASA is now having a lot of data putting in on Amazon. They're saying it's accessible. You cannot access some of them because you have to pay to Amazon. Yes. So there's some dilemma, and I really think what I like about Copernicus, I use Copernicus Marine Service data. There's nothing I need to pay for using the ZAR file they are putting in the Cloudflare. I can use as much as I want. I don't need to pay the ingress cost. I think that's something really like Europe should go on this way. But anyway, it's getting out of this.
No, but so it's not completely out of the tutorial. Yeah. If you look at to register on EOSC, you will have the compute part, which is this PanGEO EOSC here, where you have different flavor. So once you register, and if you ask for registration, we need to accept your registration. So I need to accept it. So it may take a bit of time because I'm talking right now. And then you have the second part, which is what we call the MinIO, which is the object storage, because we also want people to learn how to write on remote data. Because if you want, we talk about this fair data space where we will share data, but to share data, you cannot keep it on your laptop and you cannot keep it private somewhere in a HPC center. It needs to be exposed somewhere. So we talk about before this stack catalog, but one aspect is where do we deposit the data. So here we are showing you that when you are becoming a data provider, you can have object storage, which is very similar, Minayo, to the object storage you can have on Amazon or Google Cloud. And you can have your bucket and you can administrate the rights. So you can say, now I want to open it or I want to close it. And of course, if you want people to reuse your data, they need to be open. And in this one, using personal online storage, here we are showing you how to get access to some data from the cloud, but also to put data. And we are like Chestnut again is giving you some object storage where you can try it out once you're registered to this PanGEO EOSC.
It's mainly for trying out. So
Yeah.
You cannot put your peta of data there, sure.
No, but
It's yeah, but then you can learn. It's because it's not like a command we use with a CP something. We need to call the command of S3 CP and so on, or it's good to have somewhere that you can try for free.
so what time is it? Should we give you some time to try out, or do you want to try it on the surf at the same time? We could.
Hi, yes.
Question, lots of things I compare it to Radiant Earth now.
Yes.
Do you use something from Radiant Earth, like the data repositories or?
But Radiant Earth is this is more the other way around. They are using what PanGEO does, I think.
Sorry?
That's more the other way around. Radiant Earth is using a lot of the reusing a lot of the PanGEO, I think.
Radiant Earth? I don't
Yes.
know what it is. Sorry.
But like they have this source scope now, source scope to reposit data, to register data, you know, and like in cloud optimized,
Yes.
like Parquet
Yeah.
and
Yes.
GeoTIFFs.
Yes.
So that could be a nice place to put.
Yes.
But you don't host, right? You don't have a hosting.
Yes.
You don't have a hosting capacity, no? Do you host data?
We have
Like-
hosting.
Like we don't host data in the sense this infrastructure is too small to really be a data provider. What we have in this infrastructure on PanGEO EOSC is to show people how they can exploit current technologies to become data provider. But we don't have petabyte of data. It's
Yes.
very tiny.
Yes, that's what when the Radiant Earth is now wants to host the data. So
Yes.
we want to have this
Yeah.
public
Yes.
buckets, you know, so that could be nicely connected. Yeah, exactly. The source scope.
Yes.
So then you can make your computational notebook running directly from their buckets.
So is
Yes.
it English that would it cost the English cost, or is there is English cost free?
No, it's a project.
It's a project. But this
You
the
can,
project.
you can open it and you can see some buckets, and you can see that it's mainly environmental data. It's all open data. They wouldn't host any commercial data, of course. You have to go to beta, yeah.
So the main question is like when you put that data there,
Yes.
when you want to download it, do you have to pay it?
No.
You don't-
No, you don't
No.
have.
Yeah.
Radiant Earth is yeah, so like Eurocrop. So so that's a packet, I think.
Yes. This is also what I think Michael, you also showed something similar yesterday about the data and the annotation with OpenGeoHub when you create your stack at the end. So there are many initiatives like this, which I think are very great, and definitely we need to look at more of the metadata part. It looks very similar to what you can do with Hugging Face for the machine learning in this Radiant Earth, which is super cool. And definitely want to connect.
Yeah.
And do you make any use of Zenodo?
Yes.
Like what?
We deposit like all the images. Everything is released in Zenodo as a release.
Can you deposit from the code? Can you code to deposit on Zenodo?
Yeah, of course. Yeah, I mean,
What do you use for
with the Zenodo API, you mean?
Yes.
Yes, I mean
Okay.
the Zenodo API is not maintained by the PanGEO community.
Yeah.
It's,
you can use it.
We made a package called Zen in
yeah,
Python.
exactly. Yeah.
So you can code with it. You
Yes.
can add it.
So in the EDS book, I don't know if you have. We have tried to make this kind of Jupyter notebook and executable. So you see they have a DOI, and this is associated, for instance, with a paper. And we have the notebook, which reproduce what is done in a paper. But you can also go here, and you will have the research object, which bundle all the different research artifacts. If this is, if I can click, it's a bit slow maybe. So I suggest now you can start trying to register to EOSC, and then we can also show how to do it from the Surf Sarah. So here, if you look at the content, in the tools, you will have like the rendered Jupyter notebook, but also the Conda lock environment. So with pinned version that has been used to execute this notebook, the Conda environment and the Jupyter notebook. And you can also reproduce it if you register. You can also reproduce it in the EOSC ecosystem. So a bit similar to what is done with Radiant Earth, but maybe not so well integrated yet. Want to show?
So maybe so while people are trying to connect EOS,
we need to access.
Yeah, and then we can probably show you how it's working on the PanGEO EOS side. So who is starting this who is already starting to make the account here? Once this registration process. So just follow this registration process. You also have some like login and password for the.
Yes, if they want to try.
Yeah. So we also, if for those of you who is lazy about making the registration, you can tell us, and we can also give you the login password also.
We have some training.
We have some training account.
But you can also try directly on Surf.
On Surf, yeah.
Maybe you show on.
So while so while you are requesting the access, I will show you what the difference about the Copernicus, like the Jupyter Lab that you had on the Copernicus, and what we have on the EOSC. This is scale. Yes, hi.
No, just one question. Maybe I missed it. So in this PanGEO EOS,
yeah,
you have access to kind of the archive of the Cloudflare, or you have access to the data sets that are kind of
in the cloud.
In the cloud,
yeah,
like in the collection.
Yeah.
And okay. And are you showing the tutorial? Because I see it's really nice. Well, you were quite flexible, and so with this infrastructure, you can literally have directly access to the object storage to all these Sentinel data.
Yeah, I mean, take the cloud data that is existing, like in the Copernicus Marine Services, there are ZAR files.
Yeah.
If you find a ZAR file from their stack catalog, you can basically open from your notebook. ZAR file. This infrastructure is in the cloud, like your notebook. It's connected on internet, so you can do exactly the same thing. But the only things that different with this with your PC is like we can have the Dask gateway.
Okay.
So yours, you will have a Dask local cluster, and then this one we have a Dask gateway. And then in the last part of our tutorial, we will try on the Spider, and then we submit the job from sort of called Dask job queue, which hides Dask gateway for the HPC.
But the infrastructure has like a kind of good connection to access the cloud
So
in the backend
or not?
Yeah.
Yeah. So that's the cloud problem.
Okay.
So that it depends. I mean, if some data is around closer to the network of JustNet, and then you have a faster access.
Yeah.
If it's far, like the data is on like Amazon on the NASA side on the US, then it's slow. But it also depends. If you use like ZAR file, for example, you fast load the data, but you don't basically make petabyte of calculation. Basically, you choose certain part of the chunk, right?
Yeah.
So you have these two notebooks. So like the X-array is really for learning about X-array, and you can try and you can we can come and answer to your question, or you can raise your hand. Then you have the interactive plotting, which is interactive visualization with HoloView, which is answering to your question how we can make slider, etc. So it's fully interactive, and it can also integrate with Dask, so parallel. Then you have the data access and discovery, and this is where we are trying to show you how you can access remote data that have been produced, for instance, by us. And here we are accessing with S3FS, which is a package for accessing object storage. And here, this is when you have anon equals true, it means this is public data set. And here we are accessing this data set, which is a NDVI data, which we have produced. And when you know the bucket, you can access it, you can ls with, and you can access it with object storage path, exactly like if you access it from Amazon or from Google, but with authentication or not authentication specifying the endpoint. And you can do the analysis. And again, because it's X-array, you will only grab the data and stream the data only at the very end, because it's like you are building your graph, and at the end, it will only access the data that is needed. So so here, this is really to show this data access and discovery, how you can access data with a stack. Also, we are giving you some example, which we also have seen before, I think yesterday or at the beginning of the week. And the other one, which is chunking, is we are trying to explain you, introduce you to the parallelism, because when you have big data, you need to chunk it. And the thing is, the chunk are very important. The way you chunk your data, if you have, if you want to access a time series on one single point, but your data is chunked only through geographical area, you will have to load everything and get one point. So the way you access the data, it's very important when you produce data. The way you will produce data, you need to think about who will access my data and how. Do they want to access globally the data or on a single point? And you need to organize your data in such a way. So here we are trying to explain you what is a chunk in X-array. So when you are using Dask, you are parallelizing by chunks. So you are splitting your data, which you can split from the different coordinates, like latitude, longitude, and times. And the chunk, the size of the chunks, you have by default, depending on the data format, you have a native, what we call a native chunk, which can hinder your analysis. For instance, if someone has produced data and they have only very big chunk, it means every time you want to do an analysis, you need to put this chunk into memory and it can blow up.
Yeah, please pay attention, very important things. Yeah, so it's also, I received last days a lot of questions about, you know, how I can handle my data and this like chunking. This is like you can physically split your data, as Giuseppe was explaining on Monday, and make VRTs, tiles, and so on. That's one way. That's always it always works, and you have a lot of controls. But in Python X-arrays, this is like you have to really understand this chunking problem, because then you can easily apply on tasks and parallelize it. Yeah, so that's really like crucial to understand.
Yeah.
And so, please pose the questions, because we have experts here. So
try it out, and you can also, I really encourage you to try out on your data and to fail and to ask us, because it doesn't mean we will be able to solve it, but I would be very interested to see how you do and what you need. So here we really try to explain you what is a chunk and how you can see the chunk size and why it matters. So for instance, when you have these small chunks, it means you can distribute your data on the different processors, and you can really parallelize. If you have only one chunk, it doesn't parallelize. It means only one task will do the job only. So that's what we are trying to show you on how to access the different data. And here, this is really at the end, when you do all your chain, you can do a visualize. So I don't suggest you do a visualize when you have a lot of computation to do, because it will probably fail. Here, this is to show you how XRA will split the data depending on your chunk and your operation. And this is where we can exploit parallelism. So on the first day, what Giuseppe showed you is really how to do parallelism manually on your own, and you control the chunks. Here, the chunks are controlled through Python, but that's the same idea behind the scene. And then, so once you have these chunks, it means you can make it parallel, having more computing power behind, which is, you can show the task on the spider. Yeah,
Can
you
you use this PC right now? Because I will need to put some resource setting for the spider.
But what do you want me to do?
Okay. And then here you can click this PanGEO notebook, and then you just need to click start. And then after you click start, you should, wait a minute, you should be able to git clone as we showed before. And then start to learn the exercise like XRA and so on. And then I will once everybody is well settled in, we will explain about the Dask gateway. So what's the difference with Dask local cluster and so on? Okay. So once, as we just said, once you're connected, we recommend you to make this pip git clone, and then once you make the git clone, you should also normally have the okay, launch server start. So I'm hacking Anne's account. I hope I will not break anything. Okay, so you connect. You should have your PanGEO OpenGeoHub there. I'm just make sure that Anne have the latest version. So I pull it. Looks like now everything is fair to pull. So I guess I have to and you don't mind I cancel your change, right? Or maybe I should use my PC. You don't mind that I run it on I cancel your change stuff and so on? It's
Yes.
discard.
Where are you on PanGEO?
Discard because I need to put some new changes. Oh. So we were showing the task.
Right. That's
Oh, sorry.
We didn't pull, no?
No, I did the pull. It's just I was clicking the wrong place. Okay.
Yes. You should probably.
Okay. Close all.
Yes.
Close. Shut down all. Okay. So XRA introduction, it's done. And so right now we were in the Dask discovery. It was done.
Well, it's quickly done, but I think because what time?
We don't have our time, so
We have 1 hour.
Yeah, we have 1 hour. We want to show also the spider. So so we will show the data discovery. No, Dask introduction.
Yeah.
So we have the Dask. So you with all this chunking and so on, I guess you all now understood what's the chunk and so on.
Maybe a bit too fast.
A bit too fast. Don't hesitate to So this Dask dashboard we didn't cover it yet, right?
No.
No. Okay, that's what we want to show. Okay, so so Dask is a way to make your calculation parallel. I guess you had Dask quite a lot already this week.
They heard about it.
They heard about it. Okay, so what is Dask? Is like, so you now I think I understood that you already did a job array in the beginning of the week. So it's kind of same thing. So you have to decompose your calculation to make it parallel. When using Dask with X-ray, we use chunk. So this making a chunk is this decomposition, right? So, and then instead of you set up like a Dask, like job array, Dask will know how many chunks you have. So it's Dask who will calculate how many, how they will organize the job arrays. Am I correct for what you explained for the job array for the Monday? I'm not breaking anything. Great. So it's kind of Dask magic is like they do it for you directly from the data you wrote on X-array. For example, data you wrote on X-array, it can be NetCD file or 100 NetCD file or one ZAR file, but or GeoTIFF, which are already chunked. And then, for example, then so how then Dask understand how your data is decomposed. For example, Dask understand how you want to calculate with X-array. So when you want to do the X-array, let's say your X-array, you have like one image, it's chunked. You know, like so Atlantic Ocean and Pacific Ocean, like you have several chunks and latitude, longitude. And you, okay, let's say it's really stupid thing, you just want to multiply to 0.1. Yeah. So what the Dask will do is like Dask will see each chunk and then you multiply each chunk in parallel. And how is it happening? So Dask, so that's this workflow. Dask understand what you want do with X-array, and then Dask know how the data is chunked, so it will chunk it. And Dask have a scheduler. So it's the scheduler who will do the work of job array scheduler you use with the SLAM. So the Dask will know, okay, you guys, this part, I have 10 workers. I have 100 jobs. So I will put 10, one job on this one job on this one job on this one. Okay, you finished. Okay, you do this work. So it will schedule it. So, and then, so that there's a client, so that its client is your X-array, your workflow, and so on. That's what you see. That's what you don't see, and you don't need to do anything. Is the scheduler, which is submitting job to the the job array, or another thing is what the job array was doing. It was asking PBS, not the SRAM, SRAM to submit as many job as possible to a node. And then the node itself for us with Dask is the worker. Am I clear enough? Worker is, for example, if we do the Dask on your notebook, worker is like your cores. You have 5 cores. So the scheduler, the Dask, will say, okay, this core, you do this job. This core, you do this job, this core. So the core is workers. So that's how we distribute the task. And then, so you can, this Dask introduction notebook, first you can use what you have on your node that you have. It's like you have this Dask, this notebook itself have, for example, some cores. Let's try to use these cores in local to make some parallel computing. This is same as when you do with your notebook. So it's, or when you do it with a Copernicus, JupyterHub or Copernicus, okay? So now, when you start, what's cool with Dask on JupyterLab is there's something called Jupyter dashboard. So you click I don't know if you saw it, but you click this launch dashboard in JupyterLab, and then you go on the left, and you have this nice orange thing here. And here, you need to write slash, and this is not my keyboard, so I don't know which one to use, but I will try. No, obviously I didn't try writing.
Norwegian keyboard.
Norwegian keyboard. Proxy slash you need to write /proxy. That's
Put it in the Discord.
put it in a Discord.
You can put it in the Discord.
But it's also written on the notebook after. But
Ah.
I have it here.
Where?
My normal Clash code.
No, you.
Yeah. All right.
Yeah, okay. This
Yeah.
is /proxy,
Yeah,
but maybe we can put it on the Discord.
You need to put a /proxy there, and then that same thing with your like when you use it with you do have this with a notebook too. Okay.
Sorry.
Because that's the process that is running your scheduler. So we can look at all the information from, can you take out this one? Yeah, then fine. And then, for example, you can follow the image, and then so what we do. So on the right we have the task stream on our task, the worker memory or the progress. So you can see on your local cluster you have 4 workers here, and then so for example you can click more things on the right.
So why do you have 4 workers? Do you know?
It's because with a local cluster it checks how many cores we have,
Exactly.
and then it will
Give the maximum.
maximum. And then so if you can also self-tune it if you have a bigger we have a big a lot of cores, but you want to have workers to have more memory but less workers, because the workers, just if you have 24 giga on your notebook PC, and if you have 4 cores, it will just split your worker to have a 6 giga of memory. But if you want to fine tune it, if you want to have like more 8 cores, but with 3 giga, you can fine tune it. We can add some options on the local clusters. So you can choose different panels from the left. And for example, you can try to make your calculation go on, and you will see on the right side, like when the calculation is really done. For right now, there's nothing done. It's yeah. So right now, like, it's just checking the metadata. So it's not really doing the calculation itself. And then when it comes to this compute, that's the point that it really starts to compute. So the important things to know is like first, it looks like you run your cells one by one. It's going super fast until you say .compute or .persist, that I will say later. It's not computing anything. That's that. But that's also that's something you need to know. You can control when you really want to compute. So when afterwards, you can, because we want to show 3 different clusters. I think we are trying to do too many things at the, yeah. So I will not like show all the example of like how you can change the chunk size and so on. But when you have time, try to do these orange things, go further. You can change the chunk size. You can do different things. So that was the example of like local cluster, and I would like to show how you can have the Dask gateways.
So don't forget to
So this client close means it is killing your scheduler on your machine, so that it is releasing all the memories from these workers that you don't use anymore. And the next one, this next cell is how it will just it will connect to the Dask gateway. So what is Dask gateway is now we are using cloud services, and then there are some different Kubernetes. So it is in the Kubernetes clusters. So you are using your Jupyter Hub. Right now we run the Dask worker in your Jupyter Hub same node, but we can offload. Offload this Dask workers to the other node, which are also in the cloud. The Dask gateway will let you do that without starting like Docker image manually and so on. It's very hidden for you. So you can continue to execute the next cell. And then if you click next one, cluster equal gateway dot new cluster, this will create a new cluster for you. And then I asked the scale as 4. So I said that I want the 4 workers. And here, for example, you can click and change the size of worker. And then again, the same thing, the dashboard that we have nothing on the right, but we need to just copy this, or I could click this, and then copy this link on the top, and then put it back to this box here. Because this box is really for the connection to the scheduler, as I just said before. So we have 4 workers like before, but this time the 4 workers, it is not on the same machine that this Jupyter had, but on the machine which is just next to that. It's not in the same machine. It's kind of same thing as like you submit jobs to the like a Slurm. So don't next one you don't this is just for the Jupyter book purpose, so you don't need to execute this one. And then so for example, like cluster information, if you look at the cluster information, we have this dashboard, and then you can now run your next calculation, for example. Yeah, just by looking on the right side, it's true. It's hard to imagine like it's on your node or it's on the outside. But one thing I can maybe show you is, for example, if I do the top of the node, and then I don't see any task worker running on your on this node. Pipe this keyboard. And how do I do the pipe on this keyboard? And so if you see, like, it's Norwegian keyboard. Yeah. So you see, we should have 4 process running receive because there's a task worker, but it's not there because it's not on the same node. If you get it, what I mean, yeah. So this means like this in this example, we were just using 4 workers, but by using this task gateway, you can, for example, if you have a cloud resource, you can scale it, for example, 10 workers or 12 workers, as much as you have the resources. So this is the case of this task gateway. So you can, for example, continue to make calculations, and you would see some I guess I skipped some cells. Okay. So normally, so you can see, like, for example, it's open the data. So it's also like you will see how it's opening the data set and how it's computing. And in the end, this is using the HP plot. So how we visualize the data on X-ray. Who never used the HP plot? Okay, so HP plot, the good thing of the HP plot, it's the same thing, it's lazy. So it's use the CPU resource when you really plot it. So, for example, here you have the left the time variable. So when you change the time, and then you see the right side is working. So it means when you want to really plot it, it will make the calculation and then you plot it. So when you want to have the large scale visualization and so on, you don't really have to compute everything in a head. So you can do it on the fly. So that's how you kind of save your time and can make some make it. So if we go more in the further, so another good thing of HP plot is like if you have two, we can try to plot two things at the same time. We can also zoom it. And in this case, we're using rasterize equal true. So rasterize equal true, so it means like it's make the some, only when you zoom it, it's really go and get the high resolution data and make the computation. So that's also saves your resource of computing. So it's this option is very interesting to use. And for the people who never use HP plot, so there's this GeoTrue option, which is make it much simpler for you to plot your geo data with latitude, longitude. So if you're already using GeoPanda, HP plot, it's I guess people already using it. But it exactly works in the same way with XRA. And there are some option which doesn't work with on XRA, which works better on pandas. So sometimes things like if you directly try with XRA and it doesn't work, sometimes it's also interesting to convert XRA to pandas and then use the HP plot. Okay, so once like you try it, always don't forget to make this client close. And then also the cluster shutdown. Otherwise, the cluster you started on the cloud will be there for a while. So it's nice to release and then don't waste the CO2 because as long as the cluster is up, we are burning the CO2. We are making CO2. Yeah, we are burning carbon and making CO2. Okay. So I guess then we can, if does anyone anyone have a question about like a difference between the local cluster and DAS gateway? But no question. I think that's a bad sign because I was probably not making it understandable. The important thing is like we are offloading to the compute node outside. That's the gateway. You ask the gateway to make it. Yeah. It's basically that all the notebook is in the same format, but the notebook is same. It's just by having this one cell different, saying that's gateway, you can change your resource from your PC to the cloud. That's the point.
It's a lot, maybe for some of you, it's a lot in like a few hours, and we go quite quickly from one notebook to another. So material is there, the PanGEO Yoski is there, and you can also try it out on this Copernicus data space too, except for the parallelization part. So if you are interested, it's not like the end of today. You can still try it out later, and if you have questions, please reach out. Because we know it's difficult to understand when you are new to this ecosystem, but we also have sometimes difficulties to convey how to use this infrastructure because we are not coming from the same background. We are like more oceanographer and a climate modeler. So please, there is no stupid questions. We are most of the time stupid in the way we are explaining because maybe we are spending a lot of time on details and not on the other things. So please, you can give feedback. I know several of you, when you try to access and open the Dask dashboard, you get permission denied, and I don't really know why. So they don't manage to get it.
Okay. I will go and have a look.
And it
Mm.
may be because some of the laptop are blocking.
Yes, the pop-up,
Exactly.
another process and so on. Maybe there's somewhere on the security part saying that you
Exactly.
can access to the.
Some port.
Mm.
Yeah.
Yeah.
So it can be
So-
this. Maybe you know how to fix it.
I can pass by.
Yeah.
So,
So yeah, a few people I know that I had this trouble.
Okay.
We can try to fix it.
Yeah.
But even if you don't visualize, the computation is still done. The visualization, I never do it myself. So once you understand how it works,
I do
you-
always.
okay, you just compute and you make the computation.
It's fun to see like your calculation is really moving.
Yeah, but when you have a big computation, it's
Yeah. Oh yes, this is that. It's fun to see, but if you really do like huge calculation, when there's too many graphs and so on.
it breaks.
Yeah, it's because the visualization itself is taking your CPU, so it slows down your processing. So that's always test with small data and verify with the visualization. Once you go for the bigger thing, don't do the visualization, but always test with small data.
Yes.
That's the golden
is
rule. Yes.
Yes.
So I guess because we did a setting with our soft team, so I would like to show what about the how we can then now scale to the HPC.
Yeah.
We use the exactly same notebook, but before using same notebook, I would like you to connect again to the Spider.
So maybe you show how to shut down PanGEO.
This one, okay, okay.
Good practice.
Good practice. So I showed you how to shut down the client and the task worker, but I did not show you how to shut down the Jupyter Lab itself. That is very bad. So basically you go on the left, there's a click on the file, and then you say Hub Control Panel, and then you say stop my server. Then you're sure, and don't click start my server, but then you're sure you stop the Jupyter Hub itself because we are using a Jupyter Hub and then you are using a task worker. So task worker we killed, I show you first the kill, and now this is the one which is killing the workers. So now I guess you're not using any more CO2 from there. So let's now try to use the CO2 from Spider. So so this is explained in this set up Jupyter Lab and that's on HPC/HTC. Okay. So you just need to follow this. So as Anne first explained, so we made it with the soft team. And so they are using so when you make for example install PanGEO on your Node PC, so you make a micro Mamba and then you make a Conda environment and you install your Python environment. In case of HPC system, because they use a shared file system. Shared file system requires so many data. So when you have so many data, you have like if you have, for example, 100,000 small files, it will create a lot of metadata. So for Conda environment, it's super useful because it will install a lot of packages. For each package, there are at least 100 files creating. So when you have you can try to do the count how many files you have in your Conda environment. It's amazing. And that is a problem for HPC file system. Because when you have so many small files and so many files on each user account, that will slow down the shared file system of HPC center or HPC clusters. So to avoid that, the SAF system, they use something called container. So it's same as like what we are doing on the cloud, but they make this cloud kind of like a container work on the HPC system. That is called this Aptainer. So we're using Aptainer because the SAF system, they use Aptainer. So here, the explanation, what we will show you is how we use this Aptainer, this container on HP system to run the Jupyter and then task. So not all HPC systems have this super nice thing like obtainer. So I also wrote in the end of this example, if you're who might use other HPC system afterwards when you come back to your lab, right? So that for those people who doesn't have a singularity obtainer, I made a small boost. What if you don't have a container on your HPC down? So you can try to do that when you're back. But this is not recommended for Spider because it's not using container. It's for the people who cannot have the singularity on their other container on their HPC system. So now, first you need to log into Spider. Who cannot log into Spider? Everyone can log into Spider, right? You cannot? Really? There's one user who cannot log. You can help him? Yeah, great. Yeah, okay, then it's okay. So once you log in, so you just need to click this copy, and then copy, and then just paste it on your terminal. Next one again, you copy and click it on the paste turner. What it is doing is because we already created your singularity, the obtainer container on a shared space. So this is copying the environment that you need on your space, in your space. And then next one is creating a script for running the this container on your space with the right PanGEO environment. So once you copy that, you copy this one again, SBatch script, and normally your job starts. And I would like to connect and then show you how it's going on. But if I have Anne, let me use her terminal. I want to have a terminal on your screen. Or maybe I use my PC. That's better. I will stop sharing and I will use it. I'll use my screen, my PC. Just yeah. Okay. So I share my screen. Yeah. Okay. So I keep it for a moment. We'll just clean it a little bit. I'm showing all the mess, but anyway. So so I have configured my ssh config. This I don't know if you are using the SSH config, but you can also like put all your parameter of SSH in the SSH config, and then it's much simpler for you to connect. So voilà. So I connect the Spider. So what all I have already copied all the
Tina, can you make the terminal text a bit bigger?
Okay, sure. So as I just the script, which I asked you to copy, is already copied there. So all I need to do is this SBatch and script. And then you will have your SQ. I don't SQ you the user. So to see what kind of job is running now, and what a shame I'm running two jobs. I killed first one. Yeah. So I tried to do the screenshot. I did a screenshot on my explanation. Yes. Okay.
So before you were you had your Jupyter notebook on the Dask or maybe on other things, depending on what you did, on the PanGEO EOSC. The address on your web browser was PanGEO -EOSC, blah, blah, blah.
I can show, for example, here. PanGEO EOSC.
Yeah. So this one, now what we do, so when you are on this address, you are on the PanGEO EOS cloud, and you are on a deployment of PanGEO on the specific European Open Science Cloud. Now what we want, so we do a lot of analysis, and you can do analysis on this cloud, but let's imagine you have very, very large amount of data. So now a very large amount of processing. It's usually when you have more processing that you go to HPC. So it means now the cloud is not sufficient. You want to have more efficient machine and more CPUs. So you are going to HPC or HTC. So now we close down this PanGEO EOS. You say, okay, now I have prototyped, it works, my parallel computing, it works. Now I want to scale. So now what you do is you open a terminal. So you can close down your PanGEO EOSC web browser. Then you open a terminal and we log in on Spider, because now we want to scale big, really big. Well, Spider is not that big, but we could do something similar, much bigger machine.
And also another question is like, in case your data is not on the cloud and in case your data is on certain HPC cluster, which doesn't have access into internet, so you have to log on to this HPC center to use this data. This method is really, you cannot avoid using this method.
Yeah,
also.
But here we will use the same computation, but on Spider. So
Yeah.
open a terminal and log in on Spider, as we did at the beginning of the week and every day. So every day when we work on Spider, we open a terminal and we do SSH and we are in Spider. So now when you are in Spider, I think maybe you can show again.
Yeah, okay, that was maybe too fast.
Yeah, but I think the confusion is some people were still on the PanGEO.
Okay,
Yeah.
so once you are on a Spider,
Yeah.
what you need to go is this link of this the documentation. Set up Jupyter Lab and Dask on HPC HTC. So first, you, as Anne just said, log in to the Spider, and then afterwards you need to copy these 3 lines, and then. Okay, when you describe this copy 3 lines, and then you enter it. So that it is just making the directory for put your environment for Dask configuration. So this is the configuration that we prepared yesterday with the surf team. So we just need to copy the configuration we made yesterday to your directory.
So the goal here is that we want to scale. If we want to scale, we want to use Slurm. Because on this HPC and most HPC, you have a batch scheduler. On Spider, it's Slurm. So when we will do a Dask and we want to create workers, we want to submit a job like we did with a job array, as many jobs as we have workers. And this is done through this configuration file where we will specify what are the specificity of the machine, well, how many processors per node, how much memory, etc. And this is, it hides you the complexity when we will create a cluster on the notebook. You will not have to specify everything manually. So someone has done it for you, like a system administrator. Then it is available for everyone. So once you have copied this wrapper, this configuration, these configuration files also specify which Docker or Singularity or Aptenor image you are using. You remember when we were with using, Antonio made the presentation with HPC machine learning, we used a .cif, so an image that was prepared, and this is exactly the same. We prepared an image for this Spider, and we in this configuration file, we also specify where this image is, and this image is in a shared folder, like /project, /geocourse software, etc. So everyone can access it and can use it. Of course, you can also build your own image. This is also what we learned during this week. if you want to add new packages. So what we prepared, we try to prepare as much as possible, so you can also try to see how you can scale on a HPC. What?
There's a mistake. Just making some.
No, yes, I don't know what you're doing.
Never mind.
So the goal is to copy this configuration file. Maybe you show the copy.
Yep.
In the documentation.
Yeah.
Yeah. So when you copy this file, you mostly copy the configuration of the task on the machine, plus where the image, the PanGEO image, the .cif is located, so you can use it and you can start it when you will submit your batch job.
Yeah.
Then the next one, you have already a folder normally called scripts. This is where we put all the scripts. And we copy the batch job. So we also prepare the batch job as we did during the other days. We have a batch job that shows how to start the Jupyter notebook. So here, this is what it does. And you will submit this batch job on Spider. But then the next step will be to go back to your local machine and to open the web browser on your local machine to be able to access the Jupyter Lab from your local machine. So you are submitting a job on Spider, but we don't want to open this browser on Spider because I don't think Raymond will like it if everyone opens a Firefox on Spider. So what you do is you go back on your terminal and you will open the Jupyter Lab from the terminal, and we explain how to do that. Once you submit your job, it needs to be running. So you remember we can check with MyQ if your job is running, or SQ.
No, it's SQ, yes.
No, but MyQ, we have an alias during the training.
Okay.
So you can see if it is running. And once it is running, you can check the output of the Slurm. So you have in the same directory you submitted your job, you have a Slurm dot with a big number. If you cut this file, you will have some instruction how to connect from the local computer.
So the easiest one.
So who already managed to copy the two scripts and submit the job? It's more than 0. I'm happy. Who wants to do it and has trouble? Okay. Only 1, 2. Okay. So maybe we try to fix this problem.
I can get 2% behind. Can you wave the no? Yeah. So for those of you who succeeded to submit the job, so you should have you should have this get your job ID. And what you can do is type as it is written here, head -2 slam. You can look at it. Head -2 slam 13103524, your file. And then normally you should see this line. It says ssh.i, the key. And then what is most important is this line. This will help forwarding the Jupyter Lab, which is running on the compute node of Spider, to your PC. So this is the trick that what we need to do. So I guess you already have. This trick we will do it on our PC. So I will. For example, this PC, if to connect Spider, if I do the SSI Spider, I can connect it. But instead of just doing the SSI Spider, I guess you have your own -i and so on for connecting Spider with your credential and so on. You keep everything, but just after SSH, you just need to copy and paste this part. So this means it is forwarding the port of 8901 of compute node to your PC's port called 8889. So you just need to copy and paste this part there. And then you have nothing back, but that's normal. It is normal. It's already forwarded. If it's not forwarded, it will complain. So if you get any complaint here, that means there's a problem. Once you set up this forwarding, now you just need to start a web browser. To start the web browser, to know which address you put on your web browser, you type the command tail -3, the same output file. Just need to check the end of the output file. And you need to copy these lines. You need to copy this line and put it in your web browser. But as we said, for the port for 8889, so you have to put here as a 8889. And it's your own PC, so you need to say localhost. And then you type it. Yes, the number is also written on the documentation here. So I mean,
Yeah, but the thing is that that's why we are asking. So
Yeah.
don't hesitate to ask again.
yeah.
That's no problem.
So
You can ask again and again and again.
please ask again, 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 and then again. So if you get this Jupyter, like what you just had on the the EOS cluster, and then now you have your Jupyter lab running on a Spider cluster. So I will turn around to see if you manage to start it. Okay. Okay, then let's try to go through that more. Thank you. Then you think it's a lot of okay. So this is very important. It was for forwarding from this. Now your job is running on this node. And then Jupyter Lab had a port number 939. We go now forwarding to 8889. Okay. So let's say where do you have what do you like? We open one more patch. So how do you connect to yes, that's it. Great. So I unconnect it. In here, you just need to copy and replace No, so, yeah, yes, this one. You can just do, so this one, and the 9399. Can you try to copy this on there? And the next book way is your you just have one more time and some totally next to start. Okay, so you take the line. But just after the implementation, don't do it. Just implement the one. So minus n until 8804. This means your computer is running on not for the WN85. The Jupyter into this port are port number for the 804. So we are forwarding this information to your PC 8889.
Enormous by
Yeah. So how do you put it right? Yeah. Yes. Yes. Okay. I don't know what it is. Okay. Take that right. Jordan. Okay. So we do. Yes, it's verified, so I click this. And in here, X. In case minus 8 is the 9 yeah, because yeah, because I made that area for spider, so then I don't need okay. Okay, that's not how you run. So then yeah.
You know how to access it? Yeah. No, yeah, it was that one. That's right. When and we just put message from maybe
You want to find the essential
Sorry?
You want to find the different essential
Yeah, yes, because in the we tell do SSH with this new
dash I. SSH dash I and then the key.
yeah, but where are we don't
What is the ability? Dot SSH folder.
That's fine.
Dot SSH folder in the room.
Slash docs.
Yeah, building slash dot SSH.
Okay. Yeah, make it somewhere. I keep on familiar with mobile expression. Did you manage to achieve that?
But I have other problem, volume not found. So I'm running here, how do you just open that? So it's I have to keep right. Because I also see one person, and I know this is
It's working. So that's it's working too. Okay. Yes, managed to do something. So, yeah, wait.
Yeah, I know. I have a valid. I know what I said.
We need to add.
So.
Yes, so now it's good. So now you need to open it. Yeah. Go back. You want to find out.
Yes. Web browser that you have.
Which one is it? This is this number.
Oh, yeah.
Does anyone from
Yeah. So, yeah. Yes.
anyone else who cannot have Jupyter on Spider? Yes. The connection with you. So can I do everything? Just want to make sure you can connect with Spider with these commands.
Yeah. So you say
That's whether you have your own.
and so now you are in your
Check your job. Yes.
Yeah, yes, you can do yes, yeah. So you're looking at yeah, so you need to
If you have two SSH warning, they're trying to and also, for example, if you have a name of the so this is
yeah, exactly. So it's really when you start all of this, it's very big time.
Yes, now it's coming. Let's try. Okay, and then this token, you know how to get the token? So, yeah, also. Yeah, yes, in the end of the slide. Whether you copy and then change it if you want to leave it right? Or you give this token. But who else cannot have the slider? Okay. So I think we're getting very close to the end. Yes. Because I saw some people who are, so once that, and then, so to try the last part to see how to make the Dask work on the Spider, you need the notebook called the Dask Spider. So to have this Dask Spider, you need to also git clone our repository. Maybe some of you already done it. So I have no battery. So okay. GitHub. So if you have another terminal on the Spider, please clone our Git. And for me, it will not work because I already have it. And once you clone it, Geo. And so if you did the Git clone, and then if you go back to your Jupyter Lab that you forwarded, you have on, then you should have the directory Geo OpenHack 2024, like you had on the EOS cluster. Who doesn't have yet the Geo OpenHack 2024 directory on Spider? So everybody managed almost, hi. You need to do the Git clone now. So you have a terminal somewhere. Then you put you know, you need the Git clone for copy. Okay. Then you can do it.
I have done that. I have some other.
Okay. No problem. You have to use the Spider. Yeah. Who doesn't have yet the Git who doesn't have the screen like me, like a Geo OpenHack 2024? It's easier to see with this one. So what you should have is normally Geo OpenHack, and then you double click Docs, and you double click PanGEO, and then, wait a minute, shut down all, close all, close all. And then the spider is called Dust Spider. And then you should be able to do this Dust Spider notebook, which is dedicated for Spider right now on HPC. So it's basically it's the same, exactly same explanation as before. So you can, for example, do the local cluster. And then the point is, because we are on the PBS and the Slurm scheduler, so we can scale your computation using Dask job queue. So which is what we are trying. So we did the configuration. We copied the configuration on your local directory. This one. So this part. We copied the config. Dask config. We copied this file. Because we have this file, and then because we have this special configuration that we submitted with this container image, which the staff team prepared us, because of that, we have the neck on the left side, the same thing as the before on the cloud infrastructure. On the cloud infrastructure, we didn't have this blue thing on the left. Do you see the blue things here on your screen? So this is the point that we have that we can now scale on the Slum cluster. So you need to, as I had this, so first you click this to have this blue thing. And then now what you need to do is you just need to drag this, drop it here. Did you see it now? I do it again. So you just need to click this one, drag it, and then drop it here. And then if you exactly same, you execute this cell, and then same thing as before, you click launch the how do I say it? Launch the dashboard. Yeah, we have right stuff. And the most important thing is the next screen. You need to click the scale, and then you can choose the workers. For example, if you want to have 100 workers or something, you put it. But I guess the surf team will not be so happy about that. Yeah. And then you click scale, and what it will happen is, so this is the last part. I will wrap up.
Yeah, but we need to go for lunch now.
No. Just this one.
So, but we can do, we continue
just this
after.
one.
So, yeah, because
Okay.
we have lunch and it's a sharp time because people are preparing, they have prepared the food for us and we really need to go now. And we will continue after. I know some of you will have to leave, but
5 minutes is not a problem.
yeah. But
last
I think
minute.
it's more than 5 minutes because
it's the last minute. It's
yeah.
just 5 minutes.
But we also at the end of the day, so we will have some.
yeah, have some time.
Yeah, just say how to close it because everybody started it.
Not everybody.
Not everybody. Okay. Yeah.
It's hard to follow.
Okay. Yeah, it's just like one thing that I wanted to show is like once you do the scale afterwards, it's the same thing as that you did the job array, and it's automatically. So like you can double check that if your job is really running with the exactly same command you use on the SQ user UC, and then you will see the scale, the worker, task worker, the one which I said I want 3 workers. So that's submitted job for you. And then afterwards you can use this compute node as if you used on as the same way as you use on the cloud, same way as you use on the notebook. And that's it. That's all what I want to say. So it's just don't forget to close the cluster and then kill the job because otherwise we are burning CO2. Oh, yes, that's right. And then, so the thank you that it's super good. If you are interested, continue using the Jupyter and then PanGEO. We have also a PanGEO discourse forum. So feel free to connect to us in this Discord on the PanGEO forum. Then you can find the link. I will send you the link on the discourse. Yeah. So that's it. Thank you. Have lunch. And don't hesitate to grab me while lunch or in the afternoon or I'm in there so that I can then your help you set up configuration. Try and close.
I have one important announcement.
Yes.
Just one important announcement for people who stay at the Yasa guest house. So today is the last day when you can pay. Tomorrow is not nobody is working, so you have to pay today actually. I guess probably till the next few hours. Yeah, I think. Yeah, till 3 o'clock. Yeah, at the reception.
For the taxi, I don't know if my
Today or
yeah,
tomorrow?
today I leave with the people. She said to
Ah,
write the name until
talk
8:30,
to
but I
Cassandra.
didn't have a time.
Talk with Sandra now, so